Hey everyone, welcome back to How It Works, the channel where we make science simple and fun. Today we're diving into something that's all around us, powering our modern world, but remains invisible to the naked eye. It's the force behind your smartphone, your TV, and even the lights in your room. Let's flip the switch and uncover the shocking truth about how electricity works. You guessed it, we're talking about electricity. These atoms are like tiny building blocks, and inside each one, you'll find even smaller parts: protons, neutrons, and electrons. They're the negatively charged troublemakers of the atomic world. When these electrons decide to go on a little journey from one atom to another, they create what we call an electric current. And that, my friends, is electricity in action. What exactly is electricity? Where does it come from? And how does it travel from massive power plants all the way to your toaster? First things first, let's break down what electricity really is. In the 1750s, Franklin conducted his famous kite experiment, proving that lightning was a form of electricity. In the 1830s, Faraday discovered that moving a magnet through a coil of wire could generate electricity. This groundbreaking discovery laid the foundation for modern power generation. Just don't try this at home, folks. Franklin was lucky not to get fried. At its core, electricity is all about the movement of tiny particles called electrons. Tesla's AC system proved to be more efficient for transmitting electricity over long distances, and it's still the standard we use today. Thanks, Tesla. We also have nuclear power plants, which use the heat from nuclear reactions to create steam and spin turbines. Let's follow the journey of an electron. And let's not forget about renewable energy sources like wind turbines, solar panels, and hydroelectric dams. But here's the thing. The electricity from the power plant is at a very high voltage, which is great for long-distance travel, but way too powerful for our homes. It's like a massive, invisible highway system for energy. These clever devices can increase or decrease the voltage of electricity. It consists of a power source, wires to carry the electricity, and a device that uses the electricity. At the power plant, step-up transformers increase the voltage for long-distance transmission. Then, as the electricity gets closer to its final destination, step-down transformers reduce the voltage to a safe level for household use. These harness the power of nature to generate clean electricity without burning fossil fuels. Can cause burns. Let's lighten the mood with some fun facts about electricity. Muscle damage. And even stop our hearts. That's why it's crucial to respect electricity and follow safety guidelines. Always use properly insulated cords. Keep electrical devices away from water. Never stick anything into an outlet except a proper plug. Over 130 years ago, talk about being ahead of the curve. Built by Tesla in Australia, electricity is set to play an even bigger role in our lives. With the growing concern over climate change, we're seeing a shift towards renewable energy sources like solar and wind power. Electric vehicles are becoming more common, promising cleaner transportation. Scientists and engineers are working hard to make our electrical future brighter and more sustainable. The future is electric, and it's looking pretty exciting. Static electricity is what makes your hair stand up when you rub a balloon on your head, or gives you that little shock when you touch a doorknob. Why? Well, electricity is always looking for the easiest path to the ground, and unfortunately, the human body can sometimes be that path. Edison didn't invent the light bulb, but he did perfect it in 1879, making it practical for everyday use. He also developed the first electrical power distribution system, bringing light to the streets of New York City. Folks, the shocking truth about how electricity works, from the tiny dance of electrons to the massive power plants that light up our world, most of the electricity we use comes from power plants, and there are several ways to generate it. Electrons flow from the power source, through the device, and back to the source. It's this continuous flow of electrons that powers your gadgets. It's electrons building up in one place, just waiting to jump to something else. These safety devices detect when too much current is flowing and cut off the power to prevent damage or fires. Pretty smart, right? Now don't worry if you not a science whiz. We going to keep this simple and fun. The heat from burning these fuels boils water, creating steam that spins massive turbines. Take a moment to appreciate the incredible journey that electricity has made to reach you. It's a testament to human ingenuity and the wonders of science. These turbines are connected to generators, which use magnets and coils of wire to convert mechanical energy into electrical energy. It's like Faraday's discovery on a massive scale. It's what we'll be focusing on for the rest of this video. Everything in the universe, from the device you're watching this on to the air you're breathing, is made up of atoms. Protons have a positive charge, neutrons have no charge at all, and electrons. Think of electrons as tiny energy messengers, zipping through wires and bringing power to whatever needs it. Pretty cool, right? Now, let's talk about the two main types of electricity, static and current. Before we dive deeper, let us take a quick trip back in time and meet some of the brilliant minds who helped us understand and harness the power of electricity. First up, we have Benjamin Franklin. You might know him as one of America's founding fathers, but he was also a pretty shocking scientist. Next on our list is Michael Faraday, the father of electromagnetism. Then we have Thomas Edison, the Wizard of Menlo Park. Last but not least, we have Nikola Tesla, the master of alternating current. That we've met our electrical all-stars, let's look at how electricity is actually made. One common method is burning fossil fuels like coal or natural gas. So we've made electricity now. What? Does it travel from these power plants to our homes and businesses? Once electricity is generated at a power plant, it needs to be transported over long distances. This is where power lines come in. To solve this problem, we use transformers. The electricity travels through a network of power lines, substations, and transformers before finally reaching your home. Now that the electricity has made it to your house, how does it actually power your devices? This is where electrical circuits come into play. An electrical circuit is like a closed loop that allows electricity to flow. When you plug something in and turn it on, you're completing the circuit. But what happens if too much electricity tries to flow through a circuit? That's where circuit breakers and fuses come in. Now, as amazing as electricity is, it's important to remember that it can also be dangerous when electricity flows through our bodies. But don't let that scare you. When used properly, electricity is incredibly safe and has revolutionized our world. Speaking of which, did you know that the electric eel can generate up to 860 volts of electricity? That's enough to power a small house? Lightning strikes the earth about 100 times every second. That's a lot of natural electricity. The first electric car was built in 1884. Your brain runs on electricity too. The neurons in your brain communicate using tiny electrical signals. As we look to the future, we're also exploring new ways to generate and store electricity, from nuclear fusion to advanced batteries, and so there you have it. Thanks for joining us on this electrifying adventure. Till next time, this is how it works, making science simple and fun. See you in our next video.